Dear 12th standard students, today in this video class, we are going to see the important topic, Malus law. Before going to see the Malus law, you know about unpolarized light and polarized light. Unpolarized light contains light vibrations in all possible directions. Light is an electric vector. Generally, light is one of the electromagnetic wave. Electromagnetic wave contains oscillating electric field and oscillating magnetic field right angles to each other and also perpendicular to the direction of propagation of the waves. Here light vector is an electric vector. See, unpolarized light. In unpolarized light, light vibration in all possible directions except along the direction of propagation of waves. This unpolarized light is passing through the polarizer. Polarizer which is made up of one of the crystal. That unpolarized light made to pass through the polarizer, light come out from the polarizer, that electric field vector only one possible directions. But before passing through the polarizer, that electric field vector is all possible directions. After passing through the polarizer, that light vibration only one particular direction, which is parallel to the optic axis of the polarizer. So optic axis of the polarizer is also called transmission axis. It is the transmission axis. So light vibration only passing through the transmission axis of the polarizer or optic axis of the polarizer. See, this light is polarized light. That polarized light, the intensity is I0. This plane polarized light is made to pass through the another one crystal like analyzer. So analyzer transmission axis like this. So polarizer transmission axis and analyzer transmission axis is little bit varies. Then light come out from the analyzer. See the intensity of light. That intensity of light is varies coming from the analyzer. See, unpolarized light, light vibration all possible directions. Then the unpolarized light is allowed to fall through the polarizer. That transmitted light from the polarizer, intensity is I0, that light vibration only one particular direction. It is called plane polarized light. This plane polarized light is allowed to passing through the analyzer. That analyzer transmission axis or optic axis is angle of transmission axis of polarizer, that angle of analyzer transmission axis, that angle between these two transmission axes is different. Then light come out from the plane polarized light, the intensity is not same that of light come out from the polarizer. That intensity of light coming from the analyzer is different. See, polarizer optic axis kept constant. Then analyzer optic axis is rotated. Then notice that light come out from the analyzer intensity is continuously varies. Initially, polarizer transmission axis and analyzer transmission axis both is parallel with each other. Light come out from the analyzer intensity. It is unpolarized light, light vibration all possible directions. Then unpolarized light is passing through the polarizer. Light come out from the polarizer intensity is I0. That light vibration only one particular direction which is parallel to the transmission axis or optic axis of polarizer. This plane polarized light is made to pass through the analyzer. See, polarizer and analyzer transmission axis which is parallel to each other. Light come out from the analyzer intensity is the same that of light come out from the polarizer is I0. But polarizer transmission axis kept constant, but analyzer transmission axis is rotated continuously. See, emergent light from the analyzer intensity is continuously varies. Then intensity of emergent light or transmitted light through the analyzer is calculated by Malus, by using Malus law. Intensity of transmitted light from the analyzer is calculated from the Malus law. Malus is one of the French scientists. In 1809, he discovered When plane polarized light is allowed to fall through the analyzer, then analyzer is rotated some angle, then intensity of emergent light from the analyzer is continuously varies. From the Malus law, intensity of emergent light from the analyzer I, which is equal to I naught cos square theta. It is the expression to represent Malus law. I is the intensity of transmitted light from the analyzer, which is equal to I naught is the intensity of plane polarized light is allowed to pass through the analyzer. Theta is the angle between transmission axis of polarizer and the transmission axis of analyzer. Theta is the angle between transmission axis of polarizer and analyzer. I is the intensity of light coming from the analyzer. From the transmission axis of analyzer. I naught is the intensity of plane polarized light. But Malus discovered that intensity of transmitted light from the analyzer, which is equal to I naught intensity of plane polarized light cos square theta. Theta is the angle between transmission axis of polarizer and analyzer. See, when a plane polarized light, it is a plane polarized light, is allowed to fall through the analyzer. It is a transmission axis of analyzer. It is a plane polarized light. Transmission axis of polarizer. When unpolarized light, this is unpolarized light, light vibration, all possible directions is allowed to the passing through the polarizer. It is a transmission axis of polarizer. I symbolically represented this is optic axis of polarizer or transmission axis of polarizer. That light come out from the polarizer, light vibration, only one possible directions, which is parallel to the transmission axis of polarizer. This plane polarized light intensity is I naught. This plane polarized light is made to pass through the analyzer. This is analyzer. It is the polarizer. Then that light passing through the analyzer, that light come out from the analyzer, intensity is not same that of intensity I naught. Its intensity is varies. How much intensity of light come out from the analyzer can be calculated by using Malus law. This is transmission axis of analyzer. It is the actually transmission axis of polarizer. theta is the angle between transmission axis of polarizer and the transmission axis of analyzer. How much intensity of light come out from the analyzer can be calculated by using Malus law. It is in plane of polarizer. It is in plane of analyzer. Theta is the angle between plane of polarizer and the plane of analyzer. Plane of polarizer, it is also known as transmission axis of polarizer. Plane of analyzer is also called transmission axis of analyzer. Theta is the angle between plane of polarizer and the plane of analyzer. See, E vector is electric field vector, is also called light vector. That electric field vector is light transmitted from the polarizer is E vector. This electric field vector is essential to resolving the two components, horizontal component and the vertical component, where I0 is the intensity of transmitted light. Intensity of transmitted light from the polarizer. Then small a is the amplitude of light from the polarizer. So see the students, actually unpolarized light is allowed to passing through the polarizer. Light vibration only one particular direction, it is completely plane polarized light. Its intensity is I0, which is allowed to falling through the analyzer. That light come out from the analyzer intensity is not same that of I0, it is varies. It can be calculated by using Malus law. See, transmission axis or plane of polarizer, transmission axis or plane of analyzer. Theta is the angle between these two, but I0 is the intensity of plane polarized light is allowed to passing through the analyzer. But analyzer optic axis and the polarizer optic axis, angle between these two is theta. Then, according to Malus law, intensity of emergent light coming from the plane of analyzer is directly proportional to the component A cos theta whole square, because that amplitude of transmitted light from the analyzer is essential to resolving the two components. It is A sin theta. Another one is A cos theta. But I0 is the intensity of light coming from the transmission axis of polarizer. A is the amplitude of light coming from the transmission axis of polarizer. But that amplitude is resolving into two components. This one vector, electric field vector, makes the theta angle with this component. This component of electric field vector is A cos theta, another component, perpendicular component, A sin theta. Here, according to Malus law, light come out from the transmission axis of analyzer, which is parallel to the A cos theta component. That light field vector, that amplitude of light not come out from the perpendicular component A sin theta, because this A sin theta component of transmitted light from the polarizer is restricted by the transmission axis of analyzer. Only A cos theta component of amplitude of light is allowed to passing through the transmission axis of analyzer. So, intensity of emergent light from the transmission axis of analyzer is directly proportional to the square of the A cos theta component of light. So, I remove the proportionality, put the equal, we are introducing one constant, that is K, A cos theta square. So, I which is equal to K A square cos square theta. Here K A square is constant, I which is equal to I naught cos square theta. It is the expression to represent smallest law. This expression is help us to determine the intensity of transmitted light coming from the transmission axis of analyzer I, which is equal to I naught is the intensity of light coming from the transmission axis of polarizer. Theta is the angle between transmission axis of polarizer and the transmission axis of analyzer. If plane polarized light is allowed to passing through the polarizer, then after come out from the plane polarized light, then plane polarized light is allowed to passing through the analyzer. That the intensity of emergent light is varies when that analyzer is rotated continuously. If analyzer optic axis and polarizer optic axis is right angles to each other, then emergent light from the analyzer is 0. That intensity is 0, amplitude of light come out from the analyzer is also 0. See the students, on the basis of Malus law, we got to see two special cases. How light come out from the analyzer, intensity varies when that analyzer transmission axis is rotated continuously. It is unpolarized light. Light vibration all possible directions is allowed to passing through the polarizer. See, it is the optic axis of polarizer or transmission axis of polarizer. Light come out from the polarizer, that light vibration only one possible directions. That it is plane polarized light. The intensity of plane polarized light is I naught. Now, this plane polarized light is allowed to pass through the analyzer. See, optic axis of analyzer or transmission axis of analyzer. Both polarizer transmission axis and analyzer transmission axis is parallel. Here angle between polarizer optic axis and analyzer optic axis, theta which is equal to 0 degree. Then what is the emergent light intensity coming from the analyzer can be calculated by using Malus law. I is the intensity of light coming from the analyzer, I which is equal to I naught cos square theta. This is the first special case. Here I which is equal to I naught cos square theta 0 degree. Then I which is equal to I naught cos 0 value 1. Then cos square 0 value also 1, then I is equal to I naught. So, intensity of transmitted light through the analyzer is the same that of intensity of light coming from the polarizer is the same value. Next, case 2. See, unpolarized light. Light vibration is all possible direction. Is allowed to passing through the polarizer. See the transmission axis of polarizer. Light come out from the polarizer. Vibration only one particular direction. That intensity of light coming from the polarizer is I naught, which is allowed to fall through the analyzer. But analyzer transmission axis of analyzer is a perpendicular to both these. What happens? Intensity of emergent light from the analyzer can be calculated by using Malus law. Here, both polarizer transmission axis and analyzer transmission axis both the transmission axis is right angles to each other, theta is equal to 90 degree. What happens? Emergent light from the analyzer, I which is equal to I naught cos square theta, I which is equal to I naught cos square theta value 90 degree. So I which is equal to I naught cos 90 value 0. So therefore I which is equal to 0. So transmitted light from the transmission axis of analyzer intensity is 0. So there is no light come out from the analyzer. See, there are many cases is there. Only that important two case when both the transmission axis of polarizer and the transmission axis of analyzer both is parallel with each other, emergent light intensity of transmission axis of the analyzer is the same that of plane polarized light intensity. But polarizer optic axis and the analyzer optic axis is right angles to each other. See, the emergent light intensity from the transmission axis of analyzer is 0, which means no light come out from the analyzer. Dear students, you know that use of Malus law. Malus law which help us to determine the intensity of emergent light coming from the analyzer when the analyzer is rotated, whatever may be the angle. When plane polarized light is allowed to pass through the analyzer is rotated through some angle. Depending upon the transmission axis of polarizer and the transmission axis of analyzer angle between these two, intensity of emergent light from the analyzer is continuously changes. On the basis of Malus law, we are going to calculate one problem. See, the two polarites are kept with their transmission axis inclined at 30 degree. Theta which is equal to 30 degree. Which means transmission axis and the transmission axis of polarizer and the transmission axis of analyzer angle between these two is 30 degree. Unpolarized light is intensity I falls on the first polarite. Find out the intensity of light emerging from the second polarite. Generally, take ordinary light. Ordinary light is unpolarized light. That unpolarized light intensity is I. That unpolarized light is allowed to pass through the polarizer. Light come out from the polarizer intensity is reduced to half compared to the unpolarized light. It is an unpolarized light. Unpolarized light intensity is I. This unpolarized light is allowed to pass through the polarizer. It is the transmission axis of polarizer. Light come out from the polarizer, that light vibration only come out from the polarizer which is parallel to the transmission axis of polarizer. This intensity of light coming from the polarizer is reduced to half compared to the unpolarized light. I prime which is equal to I divided by 2. This is a general case. Whatever may be that unpolarized light is allowed to pass through the polarizer, intensity of emergent light from the polarizer is reduced to half compared to the unpolarized light. Now, this is intensity of plane polarized light is I prime. This is allowed to pass through the analyzer. Is the polarizer transmission axis is the same. It is the analyzer transmission axis. It is the polarizer transmission axis. It is the analyzer transmission axis. Angle between these two is 30 degree. What happens? Intensity of light coming from the analyzer can be calculated by using Malus law, because Malus law discovered that that intensity of light coming from the analyzer is compared with the intensity of plane polarized light. When plane polarized light is allowed to pass through the analyzer Analyzer is rotated some angle. What happens? Intensity of emergent light from the analyzer can be calculated by using Malus law. Here, intensity of light coming from the analyzer I double prime, which is equal to intensity of plane polarized light which is allowed to pass through the analyzer is I prime cos square theta. Generally, Malus law is I, which is equal to I naught cos square theta. Here, I is the intensity of light coming from the analyzer. Here, I double prime, which is equal to I prime is the intensity of light coming from the polarizer, which is plane polarized light. I prime is the plane polarized light. Cos square theta is the angle between transmission axis of polarizer and the transmission axis of analyzer. Then I double prime, which is equal to I prime cos square theta value 30 degree. So I double prime, which is equal to I prime value I divided by 2 cos 30 root 3 divided by 2 whole square I double prime, which is equal to I divided by 2 root 3 whole square 3 divided by 2 whole square 4. Then I double prime, which is equal to 3I divided by 8. It is the intensity of light coming from the analyzer.